There it is. Well, welcome everyone to the February meeting of the St. Louis Java User Group. Thanks for those of you who are in person. I hope you got a chance to grab some pizza and get a drink out of the fridge. And those of you online, I hope you have your own pizza. It's best we can do. Sorry about that. I hear Bruce has got a really good recipe, so try hitting him up. Quickly run through the intro here. I'm not going to go through all the history that Bruce likes to do, but we've been around here for a while here at the at OCI. Here in the training room is our regular meeting location. A quick update, and I'll mention this again at the end if I remember. We will not be having a meeting next month. Just due to logistics, I'm going to be out of town, and I'm the only steering committee member that's here at OCI that can help with this part of it. So we're trying to find a way to cover that gap if I can't be there. But next month, no meeting. We didn't have a speaker lined up either. So Pitch, if you have speaker ideas, I know we've got an idea from Lee. So we're looking forward to that. If you have ideas for a presentation you'd like to give, please come talk to me or another steering committee member. And yep, the regular schedule, 6 o'clock for food and social networking. Say again? Jim. Did I call you Lee? I'm so sorry, Jim. There you go. So sorry about that, man. All right, and then our meetings start at 6:30, which is in the past, so that's why we're doing this. All right, steering committee, myself, Bruce Alspaugh, Robert Levitt, and Ted Doyle. Ted and Bruce are in Columbia, Missouri, so they're not here with us tonight. They've joined us remotely. Robert and myself are here, and you can see the group email there. If you need to get a hold of us as a group, you can use that. We want to say thank you to our sponsors, of course, OCI, my employer. They let us use the training room. They often help supply the pizza. This month, that's being provided by Imply?
No, Confluent.
Confluent. Thank you, Confluent. And Manning, JetBrains, and Lee Bobbitt, who helps cover our Meetup subscription. So we thank all of our sponsors for contributing to make this Java user group possible. Okay, a couple announcements. Java 1 is coming up very quickly, a little bit later in March. And I guess there is still a discount code. Is that still good, Bruce?
As far as I know.
All right. So if you want a last-minute trip to Redwood City, California, you can save $50 off your admission. And then we have the Gateway Software Symposium, no fluff, just stuff. That's coming up in April. And there's also a good discount for JUG members there. So do take advantage of that. Early registration is ending tomorrow, I think, or this week anyway. It's coming up. So be sure to get in on that if you can. And then, of course, our perennial Manning discount code. We're very thankful for that. And thanks to Confluent, should have waited for that slide, for sponsoring the pizza. All right, upcoming presentations. April and May are already scheduled, so you can see that information there. I'm not going to read through all of them. Well, I mentioned Pratik Patel is coming in April, so that's exciting. Be good to see him again. And then Karthik Kathari is going to be presenting in May. And so we've got a couple presentations already lined up, which is great. Check out our Meetup page as well as our YouTube channel, which is also Bruce's YouTube channel. You can see our recordings of past presentations. And then please reach out if you're interested in presenting or sponsoring or joining the steering committee or anything else having to do with the Java user group. You can get a hold of us all there. So tonight's presentation is Apache Druid, Kafka's Missing Database by Dave Klein, who is a former OCI colleague and my current dad, former anchor, always dad. Yet. Yeah, that's right. But used to work right here at OCI and now is at imply.io. And maybe you'll say a word about what you do over there. So I will get out of Dave's way and please welcome Dave Klein. Please welcome.
Need the applause track. Right. All right. Yeah, my name's Dave Klein. I did used to work here at OCI a long time ago. Actually helped Zach get his job here. Taught him everything I know, and then I forgot it all. So yeah, now I currently work at, well, actually get this in a minute, but we're already talking about Apache Druid and Kafka here. I actually presented on Kafka here a few years ago, when I was working for Confluent. But now we're talking about Kafka and Druid. Apache, and yes, we'll get to all that in a minute. So then a bit more about me. I work at Imply, which is a company founded by the original creators of Apache Druid, the analytics database. Before then, I worked at Tabular, which is the company founded by the original creators of Apache Iceberg. And before that, I worked for Confluent, the company founded by the original creators of Apache Kafka. You kind of see a pattern there. But that's the type of work I've been doing as a developer advocate for all these different companies for the last 6 years or so. And I've spoken here in this meeting room for each of these 3 companies. So that's kind of, I think, the only place I've done that at. But currently at Imply, like I said, it's a company that was built up around Apache Druid, which is an analytics database. We're going to be talking more about that tonight. Currently, we're also working on a new product that's called Lumi, which is in the observability space. It's an observability data warehouse. So if you're working with an observability tool like Splunk, this is a way to leverage those tools, but load more data in at a lower cost, because storage is a real problem with observability. But that's not what we're talking about tonight. But that's what we're doing at Imply these days. And that's using the technology that's from in Druid. So we'll learn more about that. But I love Kafka. I've always loved Kafka ever since I started working with it about 7 or 8 years ago. And so we're gonna be talking about that as well tonight. So, also I'm a co-author on the book Kafka in Action. Kind of a junior co-author. The other 2 guys did most of the work, but they put my name on it anyways.
I should have brought mine to be signed.
Yeah.
The one on the cover?
Oh, no. Yeah, Manny has some interesting book covers. Never could figure that out. All right, so we're going to talk a little bit about Kafka, and then we're going to talk about Druid and how they work together. So first, we'll talk about Kafka. It's a high throughput, highly scalable, fault tolerant event streaming platform. People here familiar with Kafka? Anybody? Everybody? Pretty much? Yeah. It's a very common, one of the most common frameworks in the Java world. It's also very common in other places. When I worked at Confluent, did a training video on Kafka with Python, so it's very popular in the Python community as well. And all kinds of other language communities. It's a ubiquitous tool, and it's a powerful tool, and it's also the best invention since the wheel. I always loved that logo. Anyhow, so we're going to talk a little bit about it since most of you are already familiar with it. I'm going into too much detail on this. But Kafka is at its core, it's an event broker, or message broker, people call it. Producers will send messages or events. We like to talk in terms of events more, but that's either one works. But we send this data into Kafka from a producer. Producer sends the data, it lands in a topic, and topics are broken up into partitions. I show 3 partitions in this little simple diagram here, but you could have any number of partitions, even thousands of them. And that's the way Kafka scales. It also scales by having multiple brokers in a cluster, and then they share all that, where I think I show that in a minute here anyways. Consumers then consume that data and then use it, do whatever you want with it. It might be a stream processing application that consumes it. It might be a database like Druid that consumes it. It could be something else using Kafka Connect. The data can go to anywhere you want it to go from Kafka. As mentioning observability a little while ago, a lot of people use OpenTelemetry to grab metrics and logs and traces from applications, send it into Kafka as like a buffer, then from there into their observability framework like Splunk or something else like that. So it's used in a lot of different environments for a lot of different purposes. One of my favorite uses was always the microservices, event-driven microservices. It's such a powerful way to work with microservices, where you can have, rather than calling a bunch of API calls and a chain of API calls that one fails, they all fail, you just send events to topics when things are changing and when something needs to happen. Some other application, other microservice picks up that event, it does something with it. The next one picks up the next event, does something with it. Anytime along the way, if something goes down, the events just stack up in the topic, right? When it gets back working again, they all start flowing through again, everything keeps on running. So it's a very robust way to build microservices. It's one of my favorite uses for Kafka. Oh, there's my multiple consumers. Now, I want to show this because this is going to come into play when we talk about Druid a little bit later on too. Generally speaking, I know there's newer features with queues and stuff in Kafka, but generally speaking, your limit of scalability on the consumer side is the number of partitions in your topics. You'll generally have one consumer consuming from one partition in the topic, right? So you can have one consumer can consume from all of them. They can do that. You can consume from multiple partitions, but you can't have more than one consumer consuming from one partition. So that's your limit there. So I show 3 partitions here. We can have up to 3 consumers effectively working. We could have a 4th one. It would just be sitting kind of in standby mode until one of them died, then it would take its place. But only 3 could be actively working at a time in this scenario. Then, like I mentioned, a cluster. You can have a whole bunch of Kafka brokers, and if you have that, then they'll share the partitions of the topics. So I have one topic here, it's got 3 partitions, but I've got 3 brokers, so each broker is managing one of those partitions. Each one has all of them, but they're replicas on the other 2. So I have them here bolded, so the first one, partition 0, is the one that that broker is managing. The other two are replicas. And in the second one, partition 1 is the one that's managing, and 0 and 1, or 0 and 2 are replicas. So this provides for fault tolerance and scalability all at the same time. It's a very well-designed system, and it's probably why it's grown so, spread so widely and so widely used today. And that's all I was going to say on Kafka. I mean, there's a whole bunch more we could go. There's a really simplistic version of it, but most people are familiar with it, so I'm not going to go too deep. I will leave some more resources here, and these slides will be made available to, I think, later on, from what I heard from Bruce. I will send them to you, Bruce, I promise. But here's some more resources that you can learn more about Kafka. The various websites. Confluent Developer is a great resource. Conductor, which is has some Kafka tools, they've got a good resource there. Ivan is a vendor that has hosted or managed Kafka on the cloud. They have a lot of stuff there, and then you can also join the Confluent community, where there's a lot of really good stuff there in the Slack groups and things like that. And one other thing you can get here, and I put this in just since Confluent's providing the pizza to give them a plug for their book bundle here. These are 4 really good books. I've read parts of all of them and a couple of them all the way through. But you can get these free ebooks from Confluent using that URL there. Designing event-driven systems is one of my favorites. It's and the definitive guide is also an excellent resource for learning Kafka. So you can grab those. And now let's talk about Druid. So it's a scalable, highly concurrent, real-time database for querying, streaming, and batch data. So going back real quickly to our picture here, this one will work. These consumers are consuming this data from Kafka, and it's one event after another. It does it sequentially. Kafka stores all this data in a log, so it's an ordered log of data, so one after the other. It always runs that way. You can move around by moving to certain offsets, but you can't really seek and find things in there like that. So one of the things that's difficult to do is great for processing data in real time or near real time as it's coming. You can work with that data, do what you want with it right away, enrich the data, send it on downstream to some other process, all kinds of stuff you can do very quickly with it if it's ongoing continuous flow of data. If you later want to say, what happened last week, Kafka is not going to be very helpful. And that's where you need something like a real-time database. And that's what Druid is. So Apache Druid is a real-time database that's basically designed to work with Kafka. It also works with things like Kinesis and some other streaming tools, but it's basically designed around, in its origins, it was designed to work with Kafka. So it's really purpose-built for this. So you'll have data coming in from all these different sources. It could be data that's already been in Kafka and being processed by stream processors like Kafka Streams or Flink, and then it goes back onto the topics, and it eventually flows into Druid. And once that data gets into Druid, that's when you can start doing things like visualizations, like dashboards. You can do ad hoc querying and exploring of the data. And it's not just older data, or not just real-time data, current data, but also older, and both combined. And we'll talk about that a little bit more later too. So originally, Druid got its start in the ad space. It was basically tracking clicks for online ad services. And as you can tell, as you would imagine, there's bazillions of those coming in all at once. But you need to be able to aggregate that data, right? You need to find out how much you're going to be able to bill a customer. You got to know how many clicks for each different page or resource or whatever it was. And so aggregating that data over time is what was harder to do with the streaming technologies. So an interesting thing about Druid is that it is based on it's a microservices architecture. Some people think this is a great benefit. Other people think it's a pain. Depending on whether you're a user or an administrator. There's 6 applications you got to set up and run. You can run them all in one machine, or you can run them on multiple machines. You run them on 6 different machines, or however many you want. But you have to have those 6 services running. Well, you don't have to all of them. The router's optional, but it's really helpful. Then you also have to have 3 other pieces which aren't part of Druid. One of them is Zookeeper, which a lot of people use. Kafka used it for years, finally got away from it, but Druid still uses it. The deep storage, which is going to be an object store like S3 or Azure Blob Store, your choice there. And then the metadata store, which is going to be a database like MySQL or Postgres, something like that. And those things are used as part of the overall system. They do need to be there. So there's a lot more moving parts with Druid. Once it's up and running, you don't really see that much, but to get it going, you do need to have those things all in place. Now you see these the services, 6 services: coordinators, overlord, router, broker, middle manager, and historical. They're showing these different boxes here, and that's a common way to deploy them. And people think of these as like master nodes, which are going to have coordinators, overlords, query nodes, which have the routers and brokers, and then data nodes, which have middle manager and historical services. So the reason you put it this way is that these are the types of work that gets done. You don't normally need a lot of master nodes. Usually, most situations, one's going to be enough. These are the things that are coordinating the work, monitoring the storage, doing the replication, balancing the brokers in a cluster or the services in a cluster, things like that. The query nodes are for queries. So the more query activity you have, the more of these things you're going to need. And if you're going to be scaling those up, and that's the reason why they have these in multiple services like this is for the scale. You can scale these things independently based on your needs, and you can scale them up and down based on your needs. So if you have, for example, and this isn't too uncommon of a scenario, where you have data being written in, throughout the day, business time kind of arrangements, or not, it's like a retail thing, so it's all the time, right? Around the clock, you have data coming in. So that's your data nodes, and you keep those at a certain level to manage the amount of data coming in. That may change with seasonal things and stuff like that, right? Then your query nodes are going to probably be more active during the day when your workers that are doing the research or the analytics stuff, they're working, right? So during the day, you might have more query nodes up and running, and at night, you might scale those back down because there's less people doing queries on your data. There's more data still coming in, but no one's searching it because no one's at work, right? So that's one scenario, possible scenario. All kinds of different scenarios you might have, but by having these segregated like this, it allows you to scale them independently. So you can have more power in the place where you need it and not waste resources. So there's those things. And then just the metadata storage, I meant that's going to keep track of things like your Kafka offsets and other data that needs to be, which services are running on which services are running which machines, and what things they have that they're managing. And then Zookeeper handles a lot of the whatever Zookeeper does. And then deep storage is one of the neat things with Druid is that you have current real-time data, fresh data, and you also have older data. The older data gradually gets moved off to deep storage, which is like an object store. So it's much cheaper to store it. So you can store huge amounts of data, but in your queries, you can hit both. So if you don't need the older data, then your queries will be a lot faster. But if you do need it, you can still get it in the same query. You can get both real-time data coming in and your older data out of deep storage. And storage is kind of an important part in Druid. There's 2 reasons for Druid's success as a very fast real-time analytics database. And one's is storage, and the other is parallelism, which we'll talk about next. But the storage it is a columnar format. It's time-based, so you always have to have a time field in your data, in the data that's coming in. It's not quite like a time series database, but it leans that direction. But you need to have a timestamp, and it's all partitioned by time. You can set the granularity, whether you want it stored by minute, hour, day, however you want it, but it's all partitioned by time, and stored in what they call segment files. And it's the string fields, which are called dimensions, are stored in maps or dictionaries. So you don't store the actual text. You store the text once, and you have a key to it. So then every other record in there is going to have just a key to where that text is stored, no matter what the length of the text. So that's makes it much more efficient. And then your metric numbers are stored just as is.
I love
Yeah.
your example, sir.
Oh,
Especially the last two. Catch up in the mail.
okay. Yeah, this is a coworker's slide I borrowed. So, all right. So that's the way the data is stored. We often look at the data in rows, but it's stored in columns, and that's because when you're doing one of the most common things to do with Druid or any analytics database is aggregations, right? And those things are done across columns. So you're taking all of the certain whatever data, getting the averages or the min, max, those kinds of things. So the other thing is like I mentioned, is the parallelism in its queries. So it uses what we call a scatter gather method. Now you can have, as I mentioned before, you have these different services, the brokers, historicals, middle managers, these things. You can have as many of those as you want running, and it will share the workload across them all. So you submit a query, that query is sent to all those different services. They all will go look at different parts of the data, both real-time and older data. They'll bring their results back together and then merge them and send them back to the broker merges them and returns the results. So it can be very fast. I mean, like subsequent, basically querying terabytes of data and getting sub-second responses. If you have enough resources. And you can see here a little breakdown of this of the way the work is shared. So the historicals handle the local storage and deep storage. The middle manager handles the real-time, the data that's being ingested, which we'll show that in a minute, but you actually query data while it's coming in. And that leads us to the main thing here, which is the integration between Kafka and Druid. So as we have data coming into the partitions of the topic in Kafka, then we have, in the other diagram of Kafka, we show producers on one side and consumers on the other side. Well, basically, in Druid, some tools, some databases will use something like Kafka Connect to read the data from Kafka and then send it into your database. With Druid, it's built in, and the ingestion tasks, as we're calling them, are Kafka consumers. So each ingestion task is monitoring one or more partitions in a Kafka topic. And as the data lands in the Kafka topic, it's immediately pulled into Druid by those ingestion tasks, those consumers. And then they do some stuff with the indexing and things like that, and we'll get to those bits in a bit. We'll get those bits in a little while. And then it sends it. And so while it's even coming in, these ingestion tasks are being queried by through the queries. They're being by the middle manager. I don't show that here, but that's what does it. So you can have, again, so as far as scaling goes, you can have up to one ingestion task for every partition in the topics that you're monitoring. So we show 3 here. That's not a very good diagram, but like another thing, we had 3 and 3. You could have that again there, or you could have 1,000 and 1,000. Whatever it is, the numbers you had. And there are people with Kafka topics with over 1,000 partitions. It's not too uncommon. So these ingestion tasks, that's what we're going to look at the next several slides. We're going to be zooming in on these ingestion tasks and what happens inside of those. So as the data comes in from Kafka, it's read in and it's assigned, it's put into a receiving queue. And it's from that point, it's kind of like a buffer. It's holding in this receiving queue, and then it's parsing it and it's figuring out the timestamps on it, and it's putting it into these temporary buffers. These buffers, these in-memory buffers, are shown these white cubes, or not cubes, but blocks over there. They're basically miniature versions of the Druid segment files. They're in memory though, but they're in the same structure. So it starts breaking the data out into the Druid structure, putting it in these buffers here, based on the granularity that you have it set to. So in this diagram, we have it set for hours. It could be minutes, it could be days, it could be whatever time period you want to use. But for each of those each time period in the granularity that you set, it will create one of those buffers for each thing that comes in. And it's all based on the timestamp, not on arrival time. Which I think becomes important in a little bit later. So as the segments, as these buffers are created, they're announced, and the rest of the system can keep track and know that they're there. Oh yeah, here is it. So the late arriving data. So the one issue that you'll end up with is if you have a lot of late arriving data, you end up creating a lot more of these buffers, and that can cause memory issues. So you have to watch out for that. So now once the data's in there and it's been parsed out into the different in-memory segment buffers, as it hits certain thresholds, like the max rows in memory or max bytes in memory or a time period, that you can, all these are things you can configure. When it hits one of those triggers, then it'll start to persist that. It'll persist it to a local file. Again, it's the same format as the segments. This isn't still its final home, but it's a local temporary file that it writes to. And as it's being written there, it's turned over to the persist thread. As it's being written to disk, new in-memory buffers are being replacing that. So if you're writing I think we show it here, in fact, the 2 o'clock to 3 o'clock block, we're persisting that, right? So whatever's in there is being written out to disk, but a new 2 o'clock to 3 o'clock in-memory buffer is being created. So there's no shutdown or no lag in the ingestion. It's going to keep on coming. It's going to go in a new memory buffer that's replacing the one that just moved into the persisting phase. Then the persist thread is what does the actual indexing, and it breaks it all out into the final columns. It's going to be stored. It does the writing to the dictionaries and all those things like that are all done in that stage. And then you get a bunch of little local in-memory files that are there. And then you hit another threshold. And again, there's several different ones you can set. max rows, total rows, and a task duration. There's different thresholds you can set. When it hits any one of those, it then moves into a merge phase, where it takes all those local files you've been writing and it merges those into what's going to become the permanent segment file that'll be part of the system. Even those are somewhat temporary because you can have compaction. So if anyone has ever worked with any data lake stuff, things like that, you have compactions are very common, or even working on things like S3. You have a lot of small files. You don't want that. You can do compaction jobs that put them into, larger files that are more cohesive and stuff. So that happens with Druid. So you get these segment files. If you get a lot of them, you can get less efficient. So you can every once in a while you run compaction jobs that combines those. But those segment files that would be combined through compaction are the ones that are being written to now in this stage here. So it's taking those little local files and merging those into their final semi-final state. And again, while this is happening, there's new things being replacing the other ones, and it's all in this constant flow, so that this all is still available to be queried. Any data that's in any of these, from the point once it's past that receiving queue, from that point onward, it's ready to be queried. And then we go to the final step here, which is a publishing stage. Once it's publishing, it writes it out to the historicals and to deep storage. So it'll still be in local storage for a while and in deep storage, and then eventually it drops off of local storage and it's just in deep storage. And that happens in the publish stage, which is that's the last stage, and that's done based on a task duration. I don't think I showed it here anywhere, but there's a task duration setting. I think it was on the last slide. When it hits that setting, then that's when it does the final publish there. Okay, now we start looking at the way this is queried, because this is all queryable, as I mentioned. This is just to show a little bit of how that works. As a query comes in, it's passed off in these different threads in Jetty, and it's handed off into sends it off to I think it's the middle manager decides where to go with it, but it sends it to the various threads that are active right now. So all of those, you can have 100 of these ingestion threads running, or these tasks running. It'll send the queries off to each of those. Again, splits them all out with scatter gather. And it checks any of those incoming queries, says, do you have any data that meets my query? And if it does, it grabs that data and returns it, and it does the merge later. So it could query the in-memory buffers. It can query the persist files, the temporary files. It can query the final files. So it can query each stage in there. And then there's one thing it does this is all, again, there's a bunch of these different ingestion tasks are happening, but the one thing that needs to be, they need to share data across is for aggregations. So for group by. So if you're running a group by, then that has these extra blocks of memory that are outside of any individual thread there, and they will look across all of those threads for pieces that they need to pull in to do a group by. And let's see, then now we're nearing the end here already. Okay, here's the task duration. So at the task duration, it does the final thing where it stops all of the consuming, and this only happens for an instant. It takes those ingestion tasks that have been running and it turns them into publishing tasks. It's the same task, it's the same JVM peon it's called, but it switches its goals. So instead of ingestion, now it's working on publishing. That's what it is, the final writing to the file storage. And at that point, there's a brief pause where it makes that transition, and then new ingestion tasks are started up right away for all of the partitions. So again, in this example, we have 3 of them. So the 3 ingestion tasks become publishing tasks, and immediately, so there's a brief stop and nothing's ingested at that moment, but then right after, it's 3 new ingestion tasks are created, fired up, and the whole process continues going as it was before. So during this time period, you'll need extra memory for double the worker slots. So that's another thing to keep in mind for your memory capacity. If you set your memory so you have enough to do everything you're doing normally, when you come to these stages, you're going to run into problems. So you need to have a little bit more than that during those times. And you can configure this because you can configure the task duration. So you can actually schedule so you can have a lot more memory to things just when you know that during those time periods when the publishing is going to happen. So I said there can be a lot of things. As an administrator, there's a lot to do with Druid. For an end user, it's a dream. It works so good. But if you're managing it, it can be a little more work. And then the queries can work through all these. Queries can read from the real-time ingestion tasks at any stage, as we saw earlier. They also will read from the publishing task while they're doing their work. So there's never a time when the data that's coming to your system is not queryable. And that's a really important thing for real-time analytics. You can't have some gaps because the data is not available because something's happening with it or something, right? It's always got to be available to the queries. And with Druid, it is. And then the last step is it pushes it off to deep storage, which is going to be your object store. And then it just keeps on going. So here it shows the historicals are the ones that manage all of that stuff. Yeah, so then those ingestion tasks that became publishing tasks, at that point, they just disappear and the memory's freed up for more work. And you're back to the beginning state and going on your merry way. And that is, in a nutshell, the Druid Kafka integration. There's a lot more details involved in it, but I think it shows you clearly that it's they're meant to go. They work hand in glove. It's really, I've never seen another database that is so well designed to work with Kafka. So if you're a Kafka user and you need a database to access some of that data, and through SQL queries or ad hoc queries or dashboards or alerts or things like that, you really can't get a better tool than Druid for that. And that's what I had. And then it's some resources for learning resources for Druid. It's Apache project, so of course the Apache site has a lot of stuff. Imply, the company I work for, has a developer center which has a lot more information. We got some, I know this is a Java user group, but we have a lot of cool Python notebooks out on our site that you can use to learn and experiment different things with Druid. And there's some video. They've got a YouTube channel with a lot of stuff on there, a lot of content. And again, join the community. I think for any software that you use, if there's an active community involved around the software that you use, it'd be good to join it. I mean, it's always good just to have that resource. And also not just to get help, but also to see if you can help others. If there's a tool that you use a lot that you're pretty good at, then join the community around it and lurk a little bit, see if you can answer questions and help other people. I mean, I learned so much in the Kafka community. I think it's still one of the best. Druid's got a good group too, but not nearly as active as the Kafka one. But the Kafka community, the Slack groups, the meetups, things like that, there's just so many resources out there. So many people are eager to help. So I can encourage you to get involved in these various things. And that's all I had. I did actually have a demo at one point, but it wasn't working right now. So, and it wasn't that much. It just basically it walks you through the steps to hook up Druid with Kafka, which it's just through a browser base. That's one of the cool things with I hope none of my bosses are listening, but that's one of the things that hurt us at Imply, but it's really great for the community, is that the founders were the original creators of it, and they did not want, even as we built a commercial version of it, they didn't want anything that wasn't in open source. So everything went into open source. And so all the cool tools like Kafka is really bare bones in the open source. If you want anything more feature, you go with something like Conductor or Confluent. And then you've got your dashboard, you got your UIs and stuff like that to do things with it. With Druid, it's all built in. So Druid's got a very rich UI. One of our founders is a wizard with JavaScript visualization stuff, and so he's built a really good UI, and so it's really easy to work with. Instead, like I said, from a user side standpoint, it's really easy to get on, hook up, set up a streaming ingestion task, assign it your Kafka topics, and have it up and running. It's all based on JSON specifications, but they all can be built through the UI. So, but it's cool because it is JSON. You can also then check it into your version control systems and stuff too. So, really, like I said, a great tool. And I encourage you to look into it more if you have any need for an analytics database, and especially if you're working with Kafka. And there's my contact info. Feel free to connect. Reach out if you have any questions later. And I think I'm done. Turn on that applause track again. Yeah. Questions? Yes.
Silly question, but I'm interested in these things. Why Druid? Why did we do it?
From what I heard, it was I don't know if it was Dungeons and Dragons or something like it, but the founders were into one of those games, and that was one of the characters in it. And it was because that character was like a shapeshifter, and this whole thing, it can act like lots of different things depending on how you're doing it. So.
And Imply has something to do with COBOL.
No. I don't know where the name Imply came from. But naming companies is hard. Just ask Confluent. Or Kafka, for that matter. Try Googling Kafka sometime. You get all kinds of weird things. Yeah. Yeah, the Druid did imply, I don't know, but Druid did have a meaning behind it. Yeah.
Yeah, I have a question. So does the querying of Druid always have to happen after ingestion? Or could you like use it as a replacement for say like rocks? You can use the say enrich your message like real-time analytics.
Ooh, wow.
Can you repeat the question, please?
Oh
for
yeah,
our
the question.
online
the question-
people.
The question was if you have to always use Druid after ingestion, or if you could use it during like a replacement for RocksDB. I don't think it could go that far, because Druid is working as a consumer, and by that point you're already past the point where RocksDB has done its work, and RocksDB is mostly using things like Kafka Streams. So I guess you could, come to think of it, you could. I don't think you could do it like with Kafka Streams, which uses Rocks natively, but I think you could build your own streaming tool that used Druid for that same purpose. Yeah, you probably could. I don't know that it would be quite as snappy because Rocks is really down. It's like more of a bare metal kind of a tool. So yeah, it'd be a fun experiment though. That question.
What are your thoughts on Apache Pulsar?
Oh, instead of Kafka, right? That's I don't think about it too much. It seemed like it made a splash when it first came out, but then it didn't really go anywhere. I'm not really sure why. Other than, like I said, when Pulsar came on the scene, Kafka had already kind of taken over that market space, so there wasn't a lot of room for it. But I remember that there was some technical things that weren't it was better than Kafka at some things, but not as good at it in others, and those others were the ones that were more important to people, I think. So it just didn't really gain much traction.
Okay, that makes sense because I've heard that Pulsar is better in the way it manages and stores data, but in my opinion, most companies using Kafka don't need it. It's
Right.
resume-driven development.
Yeah, it kind of was.
Kafka on your resume, you know, put Kafka on your resume.
Yeah.
A superior product, so that's less well known.
Yeah. Okay.
If I'm coming in blind on this, what's the selling message to my boss? Right? Like, he doesn't really care about how well it connects to Kafka.
Well, it's if you need to have access to data quickly, you want to query large amounts of data, and speed is important to you, then that Druid can't be beat. I mean, ClickHouse is getting there, but I still think Druid is better. It's like I said, sub-second queries over terabytes of data, doing aggregations and stuff like that. So it's just really fast and very scalable. So you can have huge amounts of data, and it still queries it quickly. Oh yes, there are. I'm not familiar with them at all, but they are there. Yeah. So our commercial offerings that we have, they're all running on Kubernetes, since they have operators for that. I don't know if there's any of them open. They're probably open source too, because most every enhancement in Druid is open source. There's very few things that are held back for the commercial version.
Go ahead.
Okay, this is the James question. I'm imagining it's not really intended to be a transactional database. Right.
That is a good question. Yeah, it's an analytics database, so it wouldn't be the one you'd want to it's not a CRUD database. Updates are possible, kind of, but you don't want to really do that. And even things like joins, you can do them, but they're not as good as some other tools of that. It's real strength is aggregations and just fast results. You had a question.
So I still remember when KSQLDB was a thing.
Yeah, it's
How
kind of
does
sad.
this compare? It seemed like, from what I recall, KSQLDB was supposed to give us some of this. Is it just implementation?
KSQLDB was just misnamed.
Okay.
What it was, KSQLDB was trying to become Flink, and didn't work out, so Confluent adopted Flink. KSQLDB was a stream processing framework, an application basically. So it's an application you have to run on its own clusters, right? And it would take data from Kafka and allow you to build applications doing something with that data. The reason they called it the DB part is because when you do that, when you could do things like aggregations, you pull on your data and then you start aggregating it, and you can store it in data sources like RocksDB or others, that then you can view it more like a database. Still not quite like Druid does, but it's closer to that. But it was meant to do application processing, to build streaming applications, which is what people do with Flink, or Kafka Streams, which is my favorite. Now, Kafka Streams is not an application. You don't need any servers. It's a Java framework. So it's a library you put into your application, and you build your own stuff and run it on your own hardware or wherever you want to run it. I used to, when I first started working at Kafka, I was actually at Centene, and that's what we were doing there. And I love working with that. It's just really cool stuff. Yes.
If someone applied to Centene, would you encourage them to follow through or apply to a different company?
I got myself in trouble, but I would say run away. Yeah, I learned a lot from Centene. I'm grateful for that, but it was not a great place to work.
I guess just another question. So given that it's a database, I'm assuming like you have like JDBC drivers and stuff.
Yeah, there's all kinds of different drivers. It's not used a lot for JDBC drivers because it's not a transactional database. So usually what JDBC stuff is you're going to use, but you can, if you have JDBC based tools that want access to the data, you can get that data that way. Yeah.
Okay, so like say you have like an analytical dashboard, like how would they connect the data source to that data?
Like I said, so if it's an analytical dashboard that's built in Java and using JDBC, then that's what you would use. Yeah. But most of them are using other tools. So they're using BI tools, things like that, and there's drivers for all those. One more.
So I gotta ask like just a basic like the guys that don't know nothing question. So so you mentioned local files. What exactly is a local file? I know you said that some of these components run on different machines. So
yeah, okay, so that's a good question.
Local file between some other type of file.
Yeah, so when your final segment files are written in Druid, they're written to whatever storage, usually some kind of a disk storage that you have set up in your environment. That you set that in the configuration. You tell it, here's where we're going to store all our data, and those go in that more permanent data storage. The local files are going to be files that are stored to the local disk of the server that you're running on. Right, so say you're running on an EC2 instance. If you're only running on one server, it's all in the same place. Basically, it's just not going to be in the directory where your permanent files are going to be at. It's basically a temporary file. So that's probably a better way to look at it. But I say local because the way people normally deploy is they deploy it on a bunch of servers, or on Kubernetes, things like that. So you'll have a local storage for your Kubernetes things, and that's where those temporary files will be written to your local storage there, as opposed to your more permanent file system that you have assigned for your data. So another reason for this is that you might have a whole bunch of these instances. I'm going to show how you can have like the different services. You can have a whole bunch of instances running on different servers. Each of those servers is going to have some local storage for the files it's working with in that process. And then when they're all merged together, it goes to one place that all of the servers, all of them can access. Right. So your final Druid segment files are always in a single central storage place that all the application instances can get to. So that's kind of the difference. So even if you're all running on one machine, it would still be the effect would be you'd have an area like a directory that's going to have these temporary files, and you're going to have another directory that's going to have your permanent files. Hope that answers it.
Yeah, I was wondering if you were like doing something in the cloud or something like that.
Well, some of it is in the cloud. The deep storage, we call it, is in the cloud. So that's going to be S3 or Azure Blob Store or the Google's version, whatever that is. But so it's separate from that as well. But there's basically three storage places. There's a permanent file storage, there's the object storage in the cloud, and then there's also your temporary storage, which is usually closer to the process that's running.
All right. Any more questions?
All right. Well, thanks everybody.
All right.
And you get an earlier evening, and there's still lots of pizza over there. That's what you can really clap for, is a pizza.
That's right. All right. So I'll take over here for just a minute.
Do you want to go back to